Save your emergency
And
water
spring
supply.
sports start today.
Oh my gosh, no, it's the tryouts this morning. Ay.
Yeah. The winter
Dave,
sports
yes.
part.
Oh, it's 9.9. Sorry.
We have regressed.
It used to be chapter 8, and I didn't renumber my note page. Okay.
Oh, no.
So, on what was it? Thursday last week, we talked about power series, and we talked about where they converge, right? We spent some time finding radius of convergence, and then making that into an interval and figuring out what the interval of convergence would be. Okay, so now we're going to talk about taking functions and representing them as a power series. And then on Thursday, so in 2 days from now, we will talk about this idea of power series and how it relates to our Taylor polynomials and make Taylor series. And then that will be the end of our chapter. Okay? So I want you to think about this function.
We always start with
what
trig.
in my head. I was like, oh no.
Consider it.
And consider what 1 over 1 minus x might look similar to that we've seen in this chapter. What is this sum? If the absolute value of r is less than 1. So does 1 over 1 minus x follow a similar pattern to a over 1 minus r?
Wait. Gabe's absorbing knowledge.
So if we come back to 1 over 1 minus x, a is where 1 is, and x is where r is. Do you agree? Okay. So, could we write 1 over 1 minus x as the sum of n equals 1. Because our first term is 1. And our r would be x. Okay, and let's think about what this equals. This equals,
1 over 1 minus x.
well,
Oh, it's a polynomial.
where would this be centered at? Okay, we have x to the n. Nothing is being subtracted or added to x, so this would be centered at 0. And we know, without even having to do any work, what the interval of convergence would be. What is our interval of convergence? Included or not?
Not included.
Okay, let's digest how we know it's negative 1 to 1, non-inclusive. Okay, this is a geometric series, correct? And we know that the r in our geometric series has to be less than 1. Can it be equal to 1? No. So that makes our radius of convergence 1, and our endpoints are not going to allow us to converge because that would make our geometric series diverge. Okay. Basically, that's the first half of what we're doing today. We're finagling. Okay? We're going to take a function and we're going to make it look like that a over 1 minus r and write it into a power series. Okay?
Ooh.
Yes.
I heard the words coming out of your mouth. I just did not rationalize what you meant by this is the radius of convergence, and this is how we got it from 1 and x and stuff. Sorry.
Okay, well, x is in the place of r in this geometric formula, and we know r has to be less than 1. Okay, so we know that our radius of convergence is 1.
It's always
Well, I would not say always. We'll look at when it's not. But we know that the endpoints are not going to converge because we've set it up geometrically. Okay? Okay. So, let's look at the same series. But I want you to center it at x equals negative 3. Okay. Okay. In order for this to be centered at x equals negative 3, that means where this is right here, this x is in place of our r. And if we would want this to be centered at negative 3, then this would need to be x plus 3. Okay, so let's see what we can do here. We want this function, so we don't want to change the value of the function, but we want to change the way that it looks. Okay, so if we want this to be centered at negative 3, then this needs to become x plus 3. Well, if that's the case, how would we have to balance this out? What would this need to be instead of 1?
3.
4, because 4 minus 3 would get us back to that 1. Okay, now look back at that geometric formula. A over what? We have to follow this pattern right here. A over 1 minus r. Is that what that looks like? No. We need to force this guy right here to be a 1. So we're going to have to multiply numerator and denominator by 1/4. Now this looks like A over 1 minus r. Okay, so we have the series from n equals 0 to infinity. A, our first term, would be 1/4. And then our r would be the x plus 3 all over 4 to the n power. Okay. Now, I am fine with you leaving it like this. I am also okay if you say, all right, I want to combine those 4s together. So you could write this as, x plus 3 to the n over 4 to the n plus 1. That's okay. Or you can leave it like this. In a multiple choice type of question, you're probably going to see this as the answer instead, though, so I need you to understand how we get from here to here. And if you think that this looks more simple, then go for it. Okay. What is our radius of convergence in this case? Joe?
The radius is x values, right?
Mm-hmm.
So then it would be from,
I just want the radius.
I don't know, it has different boundaries based on one and negative.
We know that the r value needs to be less than 1, the absolute value of it. Well, if this is our r value, then our radius of convergence becomes what? Okay. We need the absolute value of x plus 3 over 4 to be less than 1, which means the absolute value of x plus 3 is going to have to be less than 4. So our radius of convergence is 4, making our interval of convergence -1. Oh, no. I did it the other way around. You're right. That's a -3. -7 to +1 because we are centered at -3.
I don't like the fact that it's uppercase R's.
You don't like the fact that what, Gabe?
It's lower uppercase R's. I'll probably mess with them.
I didn't hear you.
But-
Okay. I know. Uppercase R is all I got out of that.
We're using like lowercase r's for the geometric stuff, and then we're using uppercase r's for the radius, and it trips me up.
There needs to be more letters.
Maybe
We
you
should
should
start using numbers instead. We reuse them too often.
There's
There's
only
so many letters.
26.
Like, why does nobody ever use Q? Oh, we do. Or F. Oh, wait,
We do.
Oh, wait. How about what letters do you use? That's not
All the letters in your
Why not use the
We don't
Cyrillic
use
alphabet?
I never use, actually, we do.
All right. How about this guy?
Just use the Cyrillic alphabet, Gabe. No.
How about this guy?
Oh, that.
So what's the same?
Okay. Well, it's centered at 0, so.
Okay. Does this kind of follow the 1 over a? Excuse me. A over 1 minus r. I mean,
Yeah.
kind of. We would have to sort of rewrite it a little bit,
Oh
right?
no, it's gonna be converged.
This is how we would have to write it in order to look like a over 1 minus r.
Straight.
So our first term is 1. Our r is -x cubed to the n power. Okay.
Can it just be 3 plus n? It'd be 3.
What?
It'd be 3n. Oh, it would be 3n,
I would write this as -1 to the n x to the 3n. So then you could see it as that alternating series. And our interval of convergence would be
right? 1. I mean, it's centered at 0.
it's centered at 0. We have nothing funky with our, like we don't have any extra numbers in there with our R value in the geometric series. So, yes.
If it's both a geometric series and an alternating series, can you do the geometric convergence thing? Or
Yes.
do you not know? Okay. You
Yeah, if you combine them like back to here. Yeah.
So
Okay.
as long as you have the first term of one.
One more example before we talk about some operations. Did you have a question, Gabe? Did I go too fast? Did I go back?
No, I see it on the yeah, the part I asked.
L. Oh, okay. That was good.
See, I was about to ask if you were gonna put something in the numerator because it's been one thus far, but I was like, nah.
Okay, I want this to be centered at -2.
Okay.
So what needs to go right here?
X plus 2.
X plus 2. And in order to balance out our denominator to still be, in quotations, 5 minus x, what would need to go here?
7.
Because 7 minus 2 is that 5.
But now we need to divide 7 out, don't we?
Yes, now we need this right here to be a 1. So we have to. So 4 sevenths over 1 minus x plus 2 over 7.
That's a good number.
My favorite number.
Means I honestly couldn't figure out why I didn't have the right number.
4/7 might be my least favorite fraction ever.
Not 1 over 81.
What's your least favorite function?
4/7 might be my least favorite fraction.
Fraction.
4
4
over-
sevenths.
It's so close to being 1/2, and yet it's so far away.
Yes.
So 4 sevenths, Gabe's least favorite fraction, is our first term. And then x plus 2 over 7 would be our R value in our geometric series.
Can you put thetas in series?
Stop. Oh, no.
We're gonna stick with x's and n's.
I was just wondering. Theta times. No function.
What's kinda
You
No.
spend so much time focusing on being prepared. You never stop to think if you should.
If you okay, then can we put t?
Okay, so this is probably how I would rewrite it, just to combine those sevens together. Okay, and almost like isolate the x plus 2 since that's where we're centered at. Okay, since we're centered at -2, and we have a 7 in the denominator of our R value, then this is going to help us determine our radius of convergence. Remember, whatever this R value is, the absolute value of it does need to be less than 1, which means our radius of convergence ends up being 7. So our interval,
-9
That just got in my head.
to 5. Yeah, that's pretty nice.
Have you actually seen that movie? No.
what movie?
I know it from that one commercial with that.
Okay, what comment was made?
What?
Working 9 to 5. It's a good movie. That's so
Not if we're modeling it after a geometric.
Oh, I like that a lot.
Yes, I do too. I do too. Questions before we move on?
So, anything more to this?
A little bit, yes.
Oh, no.
It is a dangerous question.
I know we don't You should give the alley.
By the way, I have solutions to our problems from Friday,
Okay.
and on Wednesday we get a partner up to answer questions.
Okay.
Can you come?
Yeah.
Hesitant.
I'm in a tricky spot because I think I left my boot card at home. So, yeah.
But it's not till tomorrow.
Wow, I wrote negative.
Well, that means I couldn't run today, but then if I get it,
The
then I
radius
still
is
wouldn't be able to run
7.
tomorrow. And I haven't ran the past
Because it's
four
over
years.
7.
And so you multiply that by 7 to solve
Yeah.
the equation. But you can't separate the x
Four
into 2
choices.
because that's where it's
Oh, this is an AP problem.
Oh.
Okay, I want to talk about operations we can do with power series. So let's say we have a series with a sub n x to the n, and then we have a second series b sub n x to the n.
Well,
Wow.
I don't like this.
And each of these series are representing functions. Notice how 1 equals f of x. That means it's a function that we're representing as a series. And then the second one equals g of x. It's a function we're representing with the series.
What do we go back to this?
What?
Oh, Lord, it's
Yes, it is.
operations.
If there is a constant multiplied to x,
Can you just take it out and multiply it to a? No, wait, there's a power. Isn't there?
yeah. It also will end up getting the power along with x.
It's horrifying.
And if you want to think of this as k times x to the n, you can too, but then you can separate it, right? If x is being raised to a power, then when we go and put it in our power series, we'll essentially have a power to a power. So we would end up multiplying them.
And
I'm being consistent with our book.
I know. It's just like if you switch something has a capital N before, it's like those books when you had to practice handwriting. Capital N, little n.
Oh, I put them in the wrong order for you.
Yeah.
Sorry. If I have two functions that we are adding or subtracting, then we can write a series where you are adding or subtracting their sequences.
Is this assuming that their whatever's being raised is the same on the inside? Or does this work no matter? Like if one of them had x over 4 to the n inside.
Yeah,
of
they
the
would
one-
need to be a little more consistent, yeah. But we can add series together and squish them together.
A and B are constants, though, right?
No,
So you have a series inside of a series?
you have a sequence inside of a series.
I don't like this. Not one bit. I do not like the green eggs.
I was just trying to come up with something similar to the green eggs and handbook about your comment, but it wasn't.
I do not
No,
like
I think
this
we've
at
ascended to that
all.
point at which, like, that last year happened where I was like,
I would beat you.
there it is. But
I got it. So then,
Why do you do this?
Divide everything by x. We use j.
And why would dividing everything by x not work?
1 over x.
It's just not going to.
This is a crime against
well, if it's
humanity.
not gonna work, then why are we doing it?
X plus 1, x minus 1. There it is.
What do I
Oh,
always
no.
use this?
I'll give you a moment to figure out A and B for me.
You know,
X over 2.
This is like
Oh wow. Okay. Can you check my answers? Is that right?
I can't remember which one's positive and which one's negative, but I know that they're
The same.
those fractions.
Alright. That works in my favor.
Okay, what are we getting?
Negative 1/2 and 1/2.
I have X's instead of ones, but yes.
When you set x to a number, you put.
I do too. I have both
Yeah,
positive
positive.
one half.
Both positive 1/2?
I have
Yeah.
one positive, one negative. Okay.
I think it is supposed to be both positive, Joe, now that I look back at mine.
Oh, because that would be negative 1.
Because what I did, and I forgot that I did this, x minus 1 does us no good. But 1 minus x does us a lot of good. And so we'll subtract them so that they are modeled like geometric series. Are you okay with my switch?
Cursed.
Probably not.
Okay. So this guy is the series of 1/2 times x to the n. I'm not sure why I put it in parentheses there. And this guy is the series of 1/2. Oh, this would be negative x to the n. That's why I put it in. X to the n.
Oh yeah, I see it now. Sorry.
And this needs to be 1 minus r. So this is 1 minus a negative x. So that's why I identified r to be negative x here.
Wouldn't some portion of the second one have to also become negative because otherwise it's not the same?
What is your question?
Negative 1/2 over x minus 1. You
Oh.
need to.
Over 1 minus x.
Yeah. Wouldn't you need to make the 1/2 negative to make it equivalent?
That's what I was thinking. but
That's
yes.
why, do you see how it went from positive
Yeah.
to negative?
Mm-hmm.
That's what I did.
Oh,
I made the 1/2 negative so that I could switch the denominator.
that makes sense.
Because A was 1/2 and B was 1/2. They were both positive 1/2. So I made this a negative 1/2 so that I could write this as 1 minus x instead of x
It's a
minus
double
1.
negative because the
I,
one.
what did you ask? Because I had that, and then you asked
He-
something and I
he-
confused.
Yeah, I was just confused.
You're right. He
Sorry.
was confused and I was reestablishing it. Okay, let's make this look prettier.
Negative 1.
So 1/2, right? Times the sum of negative 1 to the n, x to the n, minus x to the n. Right, if we squish them together?
So it's the sum of negative 1.
Not really. Be patient with me here. What do those both have in common?
X to the n.
So technically you could write it like that. You could also observe that this would be x to the 0 times 0 plus x to the first times -2 plus x to the second times 0 plus x cubed times -2 plus, do you see where I'm going with this here?
Yeah, it's weird.
But what if I don't want to observe that?
Okay.
Like, would it be okay if I left it like that?
On a test type situation, this is going to be great. But what I want to show you is that this is essentially the sum of
Only the odd one.
-2 times our odd ones. How do we write an odd number?
2
2n plus 1. Well, and then we have this 1/2 out in front. So this becomes negative the series from 0 to infinity of x to the 2n plus 1.
That looks nicer, but at what cost?
But at what cost? Like I said, if you get to hear
What did it cost you? Everything.
what game?
Y'all are shouldn't even talk about odds, and I'm still copying down and stuff. You know what? It's okay.
Do you see how these are all the odd powers? X to the first, 0. X cubed, 0.
Well, I am.
X to the fifth?
but also-
Okay. So writing an odd power, we wrote 2n plus 1. 2n describes an even number. 2n plus 1 would describe an odd number.
What it says, just how you got the polynomial from all of that.
So if we plug in 0, we get x to the 0 times 1 minus 1. We good? Okay. Watch this. This right here is pretty intense. Don't panic. This is pretty intense right here. Okay? Can you get to here? I'm good.
Again. Again.
Okay. We have this one and then 2 more. Hopefully. So do you agree that this is 2x cubed times 1 over 1 plus x cubed? Do you agree with that?
Yes.
Okay. Did we already talk about 1 over 1 plus x cubed?
Yeah.
We did. We talked about how it still models that geometric series if you rewrite it to be 1 minus negative x cubed. So what we can do is we can change this right here, like we did a couple slides earlier, to be our -1 to the n, x to the 3n. That's what we did, 2 examples ago? 3 examples ago? But then we would still have this 2x cubed thrown on the outside. Well, since our series involves adding up the n's, okay, it is okay to have that 2x cubed multiplied to it, which means we can bring it inside, okay? So what would our exponent be? We would have 2 times -1 to the n times x to the 3n plus 3.
Oh boy.
How did it go to cubed? Isn't this a 2?
No, it was a
No,
cube.
it's only a cube.
It was a cubed?
Unless you want to rewrite it as a 2.
We'll keep it that way.
How can you do that? Like, isn't it like it can't converge if like the limit of it equals a number? Or is that no longer a rule applies? So you would take the limit of it, it would equal 2 because 2x cubed over x cubed is.
Well, but remember we're taking the limit as n approaches infinity,
Okay.
and so we would need to plug things in for x.
Since it's, okay.
Yeah.
Okay.
Okay. We would still have, since we
Couldn't you
modeled
make
this geometrically, we'd still have the negative 1 to 1.
I have another simplification you could do. You could make it x to the 3 times n plus 1. Like in the power. 3 is like-
yeah.
You could
Yeah.
do that.
Yeah, but that's not gonna really do us a lot of good.
It looks less 3.
Okay. It is possible that we won't get to do the integral one today, but that's okay because we can
Oh,
talk about it tomorrow.
integrals?
Okay. Okay, 1 over 1 plus x, the quantity squared. That is really nothing that we can finagle how into being something like a over 1 minus r. However, we know that 1 over 1 minus x, the quantity plus x, the quantity squared, is the derivative. Oh, shoot. Guys, this should be a minus. That'll make things go a little better for me.
One over x.
We know it's the derivative. And can we model this derivative?
Yeah.
Okay.
Negative signs.
Because that is 1 minus x to the negative first power.
Oh,
So
the
we
chain
take the
rule cancels
derivative,
out.
the chain rule cancels it out. Okay, so we know that this is the derivative of our series of just x to the n, right?
One.
Okay?
And we take that.
So it's 1 to the n.
However, when you take the derivative, now that we're working with power series, can you have 0 minus 1 power?
You can have the negative first power, yes.
Not in a polynomial, my dear. When you take the derivative, you'll need to adjust your starting place. Otherwise, you would have x to the negative 1 power, and that's not okay.
It is okay.
Okay? This had an interval of convergence negative 1 to 1. This has an interval of convergence negative 1 to 1.
Shouldn't it diverge though because of n?
You can do the ratio test if you don't believe me.
But n will go to infinity.
Can we talk about the integral one? We don't have to do it.
Yeah.
Okay, there will be one in your homework that will talk, and in your homework it'll say, it'll give you all of this, okay, for practice. Like I'm not gonna make you think of this off the top of your head right away. Okay, there is one where, like the example that I was gonna do, and if we need to look at it tomorrow, we can. Where I want the power series representation for the natural log of 5 minus x. Okay, well, we would need to use the fact that the integral of 1 over 5 minus x
Oh, okay.
would
So
give
it's-
us negative natural log of 5 minus x. And in this case, we would have to take a series and do the integral of a series.
Well, you'd also have to simplify that to be 1/5 over 1 minus x over 5 in order to get the 1 minus x on the bottom.
Yes.
Would you have to do the absolute value?
We would not need to do that. Okay, so this is your job. You need to do your book work. And then we're gonna come in here tomorrow and we're gonna talk about your book work, and if there are issues, we will work them out. I'll give you a worksheet to where you can practice this again, because I know that I've given you a lot of information, and yes, you're gonna practice it tonight, but we're gonna need to refine tomorrow, okay? And I didn't wanna take that away from you and try to push your quiz to Friday, so, but do your homework for me, so we can take full advantage of it, okay?